move on to objective 3. This is talking about how the central nervous system regulates the dual innervation of the autonomic nervous system and talking about kind of putting the two pieces together. So dual innervation is the idea that both divisions of the nervous system, the autonomic nervous system, are important even at rest, okay? There must be a balancing of these two systems. So it's not enough to have the parasympathetic system at rest, we must also have a little bit of sympathetic, right? Both of them have to be balanced. Otherwise, their heart rate will be too low, respiratory rate will be too low. And so there needs to be kind of input from both systems at rest. There's an increase in sympathetic activity that's coupled with a decrease in parasympathetic activity in order to generate certain responses. So when I think about my rest and digest response, I need to have both, I need to have influence on both divisions. So it's, again, it's not enough to just increase my parasympathetic activity. I also have to likewise decrease my sympathetic input in order to generate that type of response. And the opposite is true. So that's what we mean by dual innervation. Both systems are contributing to the function of all these effector organs. And so at rest, we actually have input. It's not equal, and I'll talk about that in a bit, but we need to have input from both divisions of the system. Let's look at an example of how the autonomic reflex response works. So basically, let's talk about an example of standing up too quickly. And typically, when we stand up really quickly, we really don't even know it or appreciate it, but most of our blood pools to our lower extremities, pools to the legs because of gravity. And so the response would be for us to get lightheaded or even faint. That doesn't happen, and here's why. There's an important responsive reflex that actually senses this change and raises our blood pressure and heart rate really quickly to compensate for that. And so we don't even appreciate any change in our perfusion because of this response. So basically, someone stands up really quickly, the blood in their body pools to the lower limbs because of gravity. And so arteries elsewhere in the body, so for example, your central arteries around your heart and lungs will detect that there's a decrease in blood pressure because all that blood pools to the lower extremities. So the visceral receptors in these central areas are going to detect that decrease in blood pressure, and they are going to send a signal to the brain, okay? The signal is communicated by a decrease in the frequency of action potentials. And so this ties into that frequency coding that we talked about. The way that the nervous system communicates different types of signals or different gradations of signals is to manipulate the frequency of the action potential. And so the way that the receptors in the central arteries can send a signal to the brain is by decreasing the frequency of the action potentials on afferent fibers. So remember, afferent fibers with an A are fibers that are going towards the central nervous system, sensory fibers. These signals get communicated to the relevant areas in the brain, so the integrating centers. We talked a lot about this as it applies to homeostasis before. These are basically your cardiovascular centers and the medulla and the pons. And these centers are going to process that information and generate a responsive action. That action will be communicated on efferent fibers. So efferent here with an E are the fibers that are sending responses. So we want to be connecting this efferent pathway to our preganglionic neuron and postganglionic neuron that are actually communicating to our effector tissues here. Now, the dual innervation bit comes in here. We don't only increase our sympathetic activity to the heart, right? It's not enough to just raise our sympathetic signals, but we also have to likewise decrease our parasympathetic activity to the heart as well. And those two actions together, that dual innervation, is what will bring about the desired response on the heart. So that will actually raise our heart rate and the contractility of the heart, so that blood pressure will then raise, and that will have a negative feedback signal onto the lower extremities, okay, which will turn off that initial signal that pools blood to the lower extremities, which is what elicited that baroreceptor response on some of our central arteries, okay? So essentially, by increasing the blood pressure, we turn off that signal, and that is a negative feedback signal onto those receptors. So this is an example of how the autonomic nervous system is bringing about homeostasis, one, but how it's kind of just active in the background without us even knowing about it consciously or even thinking about it, right? So when I stand up, all of this happens and prevents me from fainting, and I'm not even cognitively aware of it. I haven't made any decisions about that response, okay? And this is also why, as we get older and as these receptors and these responses get a little bit weaker and there's a blunting of this type of response, elderly individuals are more susceptible to things like fainting or just getting lightheaded or vertigo when they stand up really quickly. And that's because of this type of response and the weakening of this response with age. Okay. Lastly here, talking about the regulation of these two divisions of the system. So the parasympathetic system, we kind of talked about this at length at the beginning. It's responsible for the rest and digest state. This is when we're in a quiet, relaxed, kind of serene, calm state. It's going to increase gastrointestinal activity because that's what we want to be doing when we're resting, right? Digesting food. This is why we're so relaxed and kind of lazy after a large meal. It's also going to decrease heart rate and decrease blood pressure. And those are going to be some desired responses, especially when we live in a tense and kind of stress-inducing, anxiety-inducing society, okay? The parasympathetic activity, on the other hand, is going to be that fight, flight response. It's going to be important in emergency situations and stressful times, not just physical stress, but emotional stress as well. Exercise and physical activity. It's going to increase heart rate, increase blood pressure. It's going to mobilize energy store to our muscle and our liver and just kind of get the nutrients and oxygen that these tissues need to increase their metabolic demand or rate. It's also going to dilate pupils so that more light can enter the eyes and we can be more aware or more receptive to our surroundings, as well as decrease the gastrointestinal and the urinary functions. So you don't want to be digesting food or excreting waste during a time of stress, of anxiety, of an emergency response, which is the fight or flight response. And you can also add freeze here as well. So fight or flight or freeze are some of the responses synonymous with the sympathetic system. Let's talk about the tonic activity at rest. So when we're resting, we actually have contribution from both of the divisions. So there's sympathetic contribution as well as parasympathetic contribution. But the parasympathetic system is slightly more dominant, okay? So during rest, there's not this equal contribution. There's contribution from both systems, but there's a slightly more influential contribution from the parasympathetic system at rest. So this image here just illustrates some of the areas of the brain that feed into the autonomic response. We've got the cardiovascular centers and the respiratory centers that are found in the pons and the medulla. We've got the hypothalamus. This is really important for regulating things like body temperature, hunger and thirst. But we can also think about some other areas of the brain that are important in the autonomic function as well, or that influence autonomic function. So think about the limbic system. The limbic system actually controls our emotions. And so things like our thoughts and our memories, our emotional state can also influence the autonomic system activity and elicit a sympathetic response. This is why if you're anxious or nervous about maybe a test or a stressful event, or even just being in a pandemic where there's just this tense state of anxiety around you, that can actually generate a physiologic stress response on your body by increasing your heart rate, increasing just the tension because blood is shunting to your skeletal muscles, which is a part of that sympathetic response, and just that overall state of being in danger, being under stress, or just that you're in an emergency. Even though you're not physically in a state of threat or in an emergency, your body will think that you're in danger because of these types of responses, okay? And this is also why it's important to think about combating that. This is where meditation comes in and kind of mindfulness comes in. It's just understanding that that's what's happening in your body and kind of using that understanding to manipulate that. So meditating actually stimulates or generates the parasympathetic response, which can slow down your heart rate, slow down your respiratory rate, and kind of combat that state of anxiety and stress-inducing tension that we're usually under, although we're not in threat or danger. Okay. That was quite a lot. Any questions here? So that's kind of all we've got for the autonomic nervous system. This is a really, really great summary table here. So I encourage you to look at this table, and you should be able to distinguish between the parasympathetic responses and the effect on some of these tissues, the sympathetic response, and some of the receptors that are involved. Not necessarily memorize this table, but just kind of be familiar with this table, okay? The previous table with the receptors and their mechanism is much more important for you to be able to memorize and to generate from your knowledge and understanding.